In this lesson, we're going to look at how we can solve a linear system through an algebraic method called elimination. So in elimination, we want to eliminate one of the two variables. So we have the variables x and y in each of our two equations, and we want to eliminate one because we cannot solve for an x or a y when we have both an x and a y in the equation. So here's our process that we're going to use. The first thing that we're going to do is we're going to make sure that both linear equations are in ax plus by equals c format. So in front of the equal sign, we want to see our x and our y. So we have our equal sign in equation 1, x and y are in front of it, and the same for equation 2. So we already here in this linear system have both equations in ax plus by equals c format, so that's good. We don't have to do anything here. The next thing we want to do is we want to look at the variables, the x and the y, and we want to look at the coefficients in front of them. So do they have the same coefficient with different signs? Either the x or the y, not both. So here we have a positive 4x and a positive 2x for the x, so we don't have the same number, the same coefficient. Here we have a positive 3 and a negative 3 for the y. So in front of our variable y, we do have the same coefficient, 3, with different signs. So this one's being added and this one is being subtracted. So in this case, yes, we do. So we're going to go to step 4. Although before we do that, let's just quickly label our equations. So the first equation and the second equation. So step 4 says that we are going to add the first equation or the first linear relation to the second one, and that is going to eliminate one of the variables. And the reason is that we have a positive 3y and a negative 3y. So when I add 3y plus negative 3y, that gives me 0y. 0y means 0 times y, and 0 times anything is 0. So I am eliminating my variable through this method. So let's go ahead and take a look at what this looks like. In the next video, day 2 of elimination, we will look at if we do not have either the same coefficient or if we have the same coefficient but the signs are the same. We'll take a look at what we do in that case. So today we are only dealing with when we have a variable that has the same coefficient with different signs. So once again, I'm going to add these two variables, these two linear relations together. So the first thing I have, and I have to add, remember when I'm adding or subtracting, I can only add or subtract like terms. So that's part of the reason that we make sure that we're in the same format. That way our like terms line up. So I have 4x and 2x, those are like terms. 3y and negative 3y, those are like terms, and 1 and 5 are constant, so they can also be added together. They're like terms. So 4x plus 2x is equal to 6x. 3y plus negative 3y is equal to 0. So if you want to just leave it blank and not write anything, perhaps even just show that when you add them that becomes 0, that's fine. If it's more helpful for you to write in the plus 0y, that's fine. And then our last one, we have 1 plus 5, and that is equal to 6. Now at this point, if you are writing in 0y, we want to eliminate that now because 0 times y is 0. So 6x plus 0 is just equal to 6x. And then on the other side, we still have 6. So at this point, we have a coefficient in front of the x that we want to get rid of. So 6 times x, the opposite of that is going to be to divide. And 6x divided by 6 is equal to just x, and 6 divided by 6 is equal to 1. So there is the x coordinate for the solution to this linear system. So my coordinate is going to be 1 and then something else. I still have to figure out what y is. So once we have eliminated the variable and solved for one variable, So that's our remaining variable. So we've now done step 5. The next thing we're going to do is take that x equals 1 that we've just solved for, and we're going to substitute that back into equation 1 or 2. It really does not matter which one we pick. I am going to pick the 3y over here because it's positive, so I'm going to use equation 1. So in equation 1, I have 4 times whatever x is, and in this case I solved x to equal 1, so 4 times 1 plus 3y equals 1. 4 times 1 is just 4. And I want to move that to the other side of the equation. So I want to isolate the y, which means I'm first going to subtract this 4. So it's a positive 4, so I'm going to subtract it to move it over to the other side. So 4 take away 4 is going to be 0, which means I'm left with just 3y. On the other side, I have 1 minus 4, and 1 minus 4 is equal to negative 3. And the next step is going to be to get rid of our coefficient, the 3. So that's a multiplication of 3. The opposite is to divide by 3. 3y divided by 3 is y, and negative 3 divided by 3 is negative 1. So I've now solved for the y coordinate of my coefficient, and that is negative 1. Remember, our coordinates are always x and then y. The two numbers are separated with a comma, and we have brackets around them. So it doesn't matter which coordinate we solve for first. If I had the same coefficients for x, and that's what I was eliminating first, then I'd be solving for y here. Then I would just know my second coordinate in my coordinate point there. So we always want to make sure that we have x first, then y. In this case, we solved x first, which is why we're writing it first. And our last step is just to write our concluding statement. So therefore, the solution is, and then just our coordinate 1, negative 1. So remember, our solution to a linear system is just when the two equations intersect with each other. So this is the one point that is part of both of these linear relations, and that is called the solution to the system, in case you forgot. So the solution is the point of intersection, or the one point that is on both linear equations.